Welcome everyone, my name's Henry Kurth. I'm from Scantech International Australia. The presentation today is all about the benefits of real-time on-belt elemental and moisture analysis in minerals processing. Scantech has a long history of selling this technology into the coal industry and cement industry, but the focus on this conference and our major focus as a strategy is now the minerals processing industry. The presentation is quite brief, so don't get too concerned about the length of the contents page. I'm outlining some of the challenges of the industry, what's needed, what is driving the demand for new technologies, an opportunity for improvement that's been identified and that Scantech as a company has developed, some of the innovations we've included in our technologies, some of the obvious benefits we've received from existing operations. I'll include a couple of brief case studies and then just to summarise. So what are we looking for? What are companies looking for? They want improved process control. There are a lot of proven technologies out there. Most companies don't want to do a step change. They want to make incremental improvements. This allows them to be more competitive, more productive, and basically utilise their existing plant better. The overarching rule of improving anything is to start measuring it. Once you measure it, then you can control it. To control it most effectively, you need to do it in real time. Some of the challenges in terms of quality control in a mineral processing operation revolve around the ability to measure the quality of material representatively or accurately. Typically, sampling has been used probably for the last 5,000 years in some form or another. Unfortunately, in today's climate, taking a sample, sending it to a laboratory and getting it analysed isn't really a process control strategy that's effective. It takes many hours or sometimes days to get results back from a laboratory. So that sample data isn't particularly useful for process control. Other issues with sampling are it's very difficult to sample coarse materials, especially on a feed conveyor going into a process. Where those sort of sampling applications are attempted, it's a very difficult process to get a representative sample, mainly because of the particle size being quite large. It can be very expensive, and where it is implemented, many people do it quite poorly. So the results are biased because they don't sample the full stream. Sometimes they take grab samples and assume they're going to be representative. Most grab samples at that stage of the process cannot be representative. There's too much variability in the material. It can be different grades and different particle size fractions, so you have to take a proper sample. What we've seen more recently is a lot of surface analysis techniques coming into the industry. The reason is they are relatively cheap. Surface analysis systems are not going to be representative on a conveyor unless the material is very fine and it's been homogenised. And that is rarely the case on the feed to a process, which is where we're focused. The earlier in the process we measure, the better the opportunity to make an improvement. For example, if you can identify some waste on the conveyor on a plant feed and you have the ability to divert that waste, you're not spending money grinding waste down to something that you can float in a flotation circuit. So that material, or treat in a flotation circuit, so that material hasn't had money spent on it. So if you can divert waste from your process, you're making a significant improvement to the cost of the operation, and you're also utilising your plant better because you're not feeding as much waste in. So what opportunities for improvement are there? Well, it depends on what the plant benefits most from. This is an example of some work done by a very large copper mining company. They achieved different recoveries even though the average feed grade was 1% copper. To determine why that was the case, they went back and looked at their online analysis, the in-stream analysis data, and realised that the highest recoveries were when the grade feeding the plant was most consistent. So what you see there is a very strong series of trends showing that as the as the grade variability in the feed increases, recovery drops off dramatically. Most people in the industry know that a 1% increase in copper metal recovery adds millions or tens of millions to your bottom line. So you can imagine what a 13 or a 15% decrease in copper recovery means to an operation, and it's usually disaster. This is our technology, or our version of this technology. Prompt gamma neutron activation analysis has been around for 20, 30 years. We've adapted the technology so that it can be used on a conveyor for minerals. The advantage of this system is we're measuring all of the material continuously, right through the belt load continuously. That allows us to give feedback to the plant on a minute-by-minute basis. Another advantage of this system is that system there is safe to stand next to while it's operating. Okay, the shielding there is compliant with all international safety standards for radiation shielding. If there's a walkway next to the analyzer, that system does not need that walkway to be barricaded or isolated in any way. Basically, real-time analysis allows real-time process control. These photos are trying to give you an idea of the sort of material we can analyse. Now, this system is not affected by particle size or belt speed. So, another advantage being that it's non-contact. So there is no wear components in the system. It's a very efficient way, it's very accurate. Test work we have done indicates that the comparison between analyzer data and laboratory data is equivalent to 2 laboratory sets of data for the same material. So the accuracies are very good. There is very low risk in customers looking at this technology. As a result, we have over 40 installations in the minerals industry working very successfully. Here are some of the benefits. I won't go through them in detail because we just simply don't have time. Case studies I want to quickly talk to you about. One of the Geoscan elemental analyzer in iron ore in a South African operation, a copper gold operation in Asia, and a very brief discussion on some moisture analysis in the platinum industry. This case study in iron ore is from a mine that was designed after they had already evaluated the technology at another mine. So they designed the operation to benefit from the use of online analysis. The implications of that I'll talk about at the bottom of the slide, but basically this is a 20 million tonne a year operation in iron ore. It's not a huge mine, but they decided that they would use 19 elemental analyzers. They'd do a lot of processing. They use jigs and various jig circuits to upgrade different ore types. They have 6 different ore regimes or domains that upgrade by different amounts. So they need measurement to be able to recover the maximum amount from each ore type. The analyzers are used at each of 2 mines that feed an overland conveyor. The overland conveyor has an analyzer that determines whether material is product quality or whether it needs beneficiation. The amount of material that's diverted around the beneficiation plant saves them $7 to $8 million a year in treatment cost. So immediately that analyzer has a payback of a few weeks. If you look at the jig plant feed and product streams, the analyzers on there ensure that each ore type is upgraded to the optimal amount. The other units are used throughout the process, including stockpile feed conveyors, rail loadout conveyors. So they're basically managing the tonnes and quality of material right through their process. They use the data from our systems for metal accounting, for production reporting, and for overall quality control to make sure their products meet the specifications required by customers. The net impact of these analyzers on this site is that an extra 5 million tonnes a year of product is produced that does not need to go through the beneficiation process. Okay, so they can design a smaller plant to still achieve 15 million tonnes a year of product, 5 million of which doesn't go through beneficiation. The material that does go through beneficiation is more effectively processed to give you maximum recovery. The 5 million tonne a year that doesn't go through the processing plant generates around $500 million in revenue. If you started with a processing plant that was small, as they have now, that revenue would not be available because it simply does not have the capacity to treat 20 million tonnes of ore. So you can see how the process has been intelligently designed to take into account the capabilities of online analysis. The copper gold case study is an operation in Asia. They have multiple stockpiles based on drill and blast tonnes and grade. The material arrives at the stockpiles. The average grade is used to allocate it to a stockpile. Within those stockpiles, there is huge variability. It can be up to 8% copper or as low as 0.5% copper, or below if there's waste included in those zones. So the importance of controlling the copper metal feeding their plant is critical. They don't want to overload the leach circuit. They don't want to underutilise the leach circuit. This customer uses a 5-minute measurement increment. Typically we use a 1 or a 2-minute measurement increment. They composite those 5-minute measurement increments to half an hour to give them a metal tonnage for that half an hour, and then they adjust the blend from the stockpiles up here, where they have multiple stockpiles, if they need to adjust the copper metal content. The payback from this customer was calculated to be 2 months, so they obviously felt they could save a lot of copper. In platinum, generally, the main applications of our technologies are for moisture control or moisture measurement. In this case, it's mainly a metal accounting, where there's multiple underground operations feeding a central concentrator. Each mine has a different moisture content, so as soon as the material's hoisted, put on a conveyor, they measure the moisture content to be able to allocate platinum grade or allocation back to each mine. So in summary, these technologies and these systems are proven. We've been using them for over 12 years in minerals. We've got them in various applications. They're giving great benefits to every single customer that is using them. And in effect, they're saving millions of dollars a year. And we've seen that from our customers telling us that. So the return on investment is very quick. Our booth, 112, over in the zinc area. So if you would like to talk to us more about the technology, please come and see us at our booth. Thanks for your attention.